Hello, everybody, and welcome to this webinar. You will be muted during the webinar, but if you have any questions or comments, you can use the question section at any time during the presentation. We will also provide some time for writing your questions. The webinar will be recorded, and in a few days, we will send you the link to the recording. Today's topic is structured systems engineering with Word, Excel, and PDF, powered by SES Engineering Studio. And what we will learn is how to bring structure to Word, Excel, and PDF without changing your tools. The presenter today is Raya Shelkar, and my name is Cecilia Karlsson. So, what do we do at the Reuse Company? We provide a platform and a set of well-defined methods to support the implementation of an incremental and comprehensive reuse process. The approach is based on knowledge management and elicitation, quality assessment, interoperability across tool ecosystems, artificial intelligence, and smart search engines. Now I'd like to introduce you to the presenter, Raya Shelkar. He is a systems and solutions engineer here at the Reuse Company. Raya has a master's degree in systems engineering and is ASEP certified from INCOSE. He has experience in system design engineering and specializes in model-based systems engineering, SysML, and system certification and validation. So let's start with today's topic. Hello, Raya.
Hello, Cecilia, and hello, everyone. Thanks for the introduction about the company and my profile as well. So let's start with the agenda for today's webinar. First, we'll try to understand what are the problems engineering teams are facing, which slows them down. Second would be how one can stop managing PDFs manually with a demonstration as well. Third, how one can stop managing requirements without structure. Fourth is how one can understand what breaks when something changes, focusing on traceability. And the fifth part would be conclusion. With that, I would like everyone to take a couple of seconds to think about what would slow an engineering team. Now let's see whether we all have a particular alignment about the problems or not. So first could be managing stakeholder requirements, which would be in the form of PDFs. Second, rework caused by late issue detection. Third could be requirements created in Word without structure or consistency. Fourth, broken or incomplete traceability. And fifth, change impact discovered too late. I hope we might be aligning with these problems. If so, let's talk about our flagship product, which is SES Engineering Studio. What it does, it connects, analyzes, and governs data across your existing tool. And the most important term here is existing tools. The purpose of SES is to integrate into your existing toolchain. It adds structure and control on top of your existing documents and tools. Some of the capabilities which it contains is structured requirements authoring as well as analyzing them. Second is interoperability without replacing your tools. Third is end-to-end traceability across the engineering lifecycle. These are some of the capabilities, and this image shows the number of capabilities that the SES Engineering Studio, our flagship product, contains. With that, now let's see how one can stop managing PDFs manually. The problems an engineer faces. First could be extracting and managing stakeholder requirements. Second, quality issues are discovered late. Review cycles are manual, slow, and could be subjective. How SES approach can help to solve these problems? So first could be automatically extract structured requirements. Second, requirements quality analyzer, focusing towards automatically analyzing and flagging the quality of requirements. The impact by implementing this approach is 60% reduction in requirements review turnaround time. Second is fewer review iterations. Third is higher quality requirements earlier in the life cycle. I would like to demonstrate how these impacts are actually seen in a real project. So with that, let's move towards a video. This is my document, which contains stakeholder requirements, which is in the PDF format. Now, this is the SES interface, and I'll be adding a connection of PDF into the environment. I can configure it as per my rules, whichever I set. I do have the option of selecting the identifiers. With that, I'll just name this connection for unique identification, and let's open it. With that, you can see the SES interface, which contains the column of ID, description, as well as author. We do have the option of increasing the attributes, which we would see in a couple of minutes. Now I have saved this information into my database. The next feature is to create an attribute glossary so that we can use it for other projects as well or other connections. I'll be creating some enumerations for me to select the appropriate value and aligning them with the attributes. So my attributes would be focused towards status, priority, effort. Additional attributes such as comment as well as team will be added. I'll give this glossary a name and I'll configure my connection to particularly add these attribute glossaries. With that, let's open the connection again. Manage the columns. And I'll be able to add attributes as per the need. So here I'll select comment, effort, priority, status, and team. With this, you can see that attributes are included into my interface. And I do have the option of selecting the values as well. Let's save this information for now. Now the next step would be to analyze these requirements, and the value which we bring with this particular capability is to have a quality analysis in a structured way with certain set of rules which are customizable according to the need of an engineer, project, or the organization. So I'll show the metric set templates. I do have two, which contains the set of rules and specifically related to INCOSE 42 set of rules. Now we are moving towards the RQA, which is Requirements Quality Analyzer interface, wherein we can see the ID, work products, and the approach which we use is CCC, which is correctness, consistency, and completeness. With this approach, let's assess the requirements. Based on specific rules, we tend to get the quality analyzed, and the requirement 13 contains issues which needs to be addressed by an engineer. So we can then move, also look into the reports. We do have the option of creating a report and exporting it in the format which we desire. I can also export it in the Excel format. Likewise, I can get the entire information of the analysis. We'll again move back to the previous particular interface and add certain comments related to stakeholder requirements 13 because it is of not good quality. This is related to requirements authoring and analysis. Now let's see how one can stop managing requirements without consistency and traceability. The problems engineers face: managing requirements in MS Word. Requirements authored in Word lack consistency and traceability. Store baselines, track changes, and evaluate their impact. Fourth is generate customer reports. The SES approach, it helps to connect with existing tools like PDF, MS Office, Capella, etc. Second, RAT, which is Requirements Authoring Tool, helping to author structured requirements. Third, configuration management and report generation. Using this approach, the impact which we have seen in different projects is 40% reduction in requirement generation and fewer manual errors, as well as faster collaboration across domains. With this, I would like to demonstrate the impact in real-life projects as well. We'll start with requirements management in MS Word. Our tool has the capability of managing the requirements in MS Word itself using a plugin. So we'll move towards the requirements section, which contains different requirements. With SES Engineering Studio, we can connect and we can configure it based on certain rules which the engineer desires. I do have the option of filtering as well. And with this, on the right hand side is the SES interface, which shows that all the necessary requirements have been included. Now, the next thing which we will see is addition or deletion or modification of requirements, which is possible using a value adding capability requirements authoring tool. So first, let's include a pattern. And why do I select a pattern here? The reason being, I would be using this pattern to create number of requirements. So I selected a pattern group which contained number of patterns. And with that, we'll now move towards our RAT, which is Requirements Authoring Tool Interface. You can see I'm getting suggestions by the tool itself. So that's an interesting feature of the tool, as it provides suggestions so that it's easy for an engineer to write a structured requirement. This requirement is of good quality and it gets included into both interfaces. We can save this information and it gets loaded in the source tool as well. The next operation which we will do is to modify a requirement and see if the changes happen in both interfaces, that is on the left hand side as well as on the right hand side. So as you see, both the interfaces have been updated. Now let's try to delete a requirement. And it gets highlighted in red. And once I save it, that information gets erased from the source. Now what I do is I'm trying to change my particular IDs, but that's not possible, and it has been intentionally done so that the IDs remain and the version control is appropriately managed. Now we move towards report generation, a capability important for having customer reports in a specific template. The next thing we do is go into the reports template. I have an existing report with a certain format, and in the report requirements and trace section, I'll add repeating sections with certain attributes which is of importance for my report. It contains the IDs, description, priority, and as well as status. I'll also include some traces. We will see how to create traces in the next section, but I have an option of creating traces in the reports as well. Once I save and close this, the template gets ready, and in just a click, I can have the report generated, which contains my requirement, the priority, the status, as well as the traced requirement. I can export it in different formats, in Word, in PDF, etc. For now, let's do it in Word, and all the information gets created in the Word format as well. The next thing, let's try to focus on configuration management. And the value this capability adds is to create some baselines, check the differences among the baseline and the current version, and also see if there are any traces available. So this is my document. I can create a baseline quickly. Let's name it as SOI requirements underscore version 1. I'll update certain aspects of the document. I'll change another requirement. I'll also add a requirement just to increase some complexity for configuration management. Change the attributes. And also delete a requirement. Once saved, I'll be doing a difference check between the previous version on the left and the current version on the right. And all the information gets highlighted here. I can also go into a requirement, see the markup to check what exactly was removed, modified, or deleted. I also have the option to check the traces to understand the impact analysis. Now, an interesting feature is to see the change identification for attributes modification as well. So for one of the requirement, I'll just change some attributes. Let's say requirement 17 and requirement 18. I'll check the differences once it is saved. And as you can see, requirements 17 and 18 gets highlighted. We'll just see the changes which have happened, and in the label format, you will be able to see if there are attribute changes that can also be highlighted. So with that, we have checked requirements management in MS Word. Now let's focus towards another capability, which is traceability. So the problems engineers face. First is trace links are manual and fragile. Second, changes break traceability. Impact analysis is time consuming. The SES approach, which helps to cater these problems. First is create and maintain automatic and manual trace links. Second, trace across complex multi-tool environments. Third, keep traceability consistent as data evolves. The impact this approach helps to create is up to 50% reduction in traceability and impact analysis turnaround time. Second, faster, more confident change decisions. And third, support for audits and regulatory compliance. With this, let's see a demonstration of this capability as well. Connecting risk and test Excel files. So earlier we saw that PDF connector can be added into the SES environment. Now let's see whether Excel files are possible or not. This is my Excel file which contains risk with different columns. I can add connection, and I'm very much proud to say that the tool has the capability to connect almost 50 other tools. We'll do a mapping which can be configured as per the need of an engineer. or the person using this tool. We'll name this connection as risk catalog. With that, you can see the necessary information gets included in the SES interface. Likewise, I also created similar scenario for test cases as well, that is mapping it with the SES environment. I'll save this information in my database. Now we'll see traceability between PDF, MS Office tools, and Capella, which is an open source modeling tool. This traceability would be manual as well as automatic. So all the documents are open. We have 5 documents. Now in Traceability Studio, we'll create a project. Let's say traceability underscore MS Office. And in this project, number of modules would be created. First, let's start with stakeholder requirements to control system requirements, which is a connection between PDF and a Word file. Similarly, I'll create another module, which is between Word and an Excel file, that is the source and the target documents. The next would be Capella elements to an Excel file with selecting different trace types. Individual has an option to create his own trace types as well, or use the default ones, whichever he desires. Similarly, let's create one more module to see the capability of having a good impact analysis. Now we'll go into one of the module to check how one can create manual traces with just a click, and also include a rationale if needed. I'll just include derived requirements for now. The next thing which we will focus is towards suggestion algorithms. And this is the section wherein one can have automatic traces generated with the use of different algorithms the tool has. So for now, we'll use semantic retrieval, which will help us to identify the traces between requirements having similar semantics or words. So in a couple of seconds, I'll get the trace suggestions. For now, I have 4 trace suggestions, and an engineer has the capability to either accept the suggested trace, which becomes consistent, or remove the trace, which helps it to delete. Similarly could be done for documents, but the interesting part is also for Capella elements with an existing document. Let's say Capella with test cases. I can create manual trace as well as I can do automatic traces if needed. Now, there are different traces which are being created for different modules. Module which contains the source and the target document. We can also see a module map, which typically tells us the different connections between the different tools, and also how many traces are present, whether they are consistent, whether they are suggested, or in suspect state. Now, let's open one of the module. A matrix can be developed. So in this scenario, we do have a matrix wherein different requirements are connected with each other. We can also create a trace using the matrix as shown. Requirement 21 is connected, and at the top you can see a trace has been generated. So with this, we have seen about requirements quality analyzer, requirements authoring tool, and the traceability module. Next, I would like you guys to think and ask your questions, and we can wait for 30 to 40 seconds so you gather your questions, and then we could answer them as per our understanding. Cecilia, over to you.
Okay, thank you, Rayas. We have some questions dropping in, so let's start with the Q&A. Let's see. Am I correct in thinking that the data repository that SES creates is entirely local to the user or organization, and it doesn't need cloud services or data transfer to the reuse company?
Okay, so thanks for this question. To answer it, the repositories can be local on-premise. So it helps the user to completely have control on their data. And this would help them to use it as per their need. And typically we use SQL Server, MySQL, and Microsoft Access as the databases.
Okay, thank you. The demo requirements are very well written. What happens when the requirements are poorly written?
So when the requirements are poorly written, the tool with the set of rules identifies the issues in it, and the engineer or the user has the capability to modify it for their particular need of the project.
Okay. Next question. When using the trace tool, where is the trace data stored?
So the trace data is stored in the SES Engineering Studio.
Okay. I understand that there is several algorithms to automatically retrieve the traces. How much can I rely on it?
That's a very good question. And the reliability is these algorithms are developed based on certain rules. So one can completely depend on them, but one also has the opportunity to evaluate it, because in the rational section, particular rationals are being provided by the tool itself. For example, if we see the semantic retrieval which I showed, it gave me a rationale that the semantic retrieval process used 50% checking of semantics. So based on that, one can make his decision about choosing the accuracy.
Okay. How are versions tracked and saved when doing diff?
Could you please repeat the question, Cecilia? I couldn't hear it properly.
How are versions tracked and saved when doing diff?
Okay. So once the engineer, first of all, has the option to create different versions, and as I had shown in the configuration management capability, one can see the differences between them. It's not only for a particular baseline, there can be number of baselines, and one can check based on the current version or the previous versions as well. So for example, if I create 4 different baselines, I can compare version 1 with version 2 or version 1 with the version 4, in quotes, version 4 being the current one.
Okay. And another question, does SES Engineering Studio integrate with tools like Doors, JAMA, or Capella?
Yes. So SES Engineering Studio has the capability to connect with almost 50 tools. It includes textual tools like Doors, MS Office, etc., as well as modeling tools like Capella, Cameo, and the simulation tools as well.
Okay, we have no further questions right now. So thank you, Rayas.
Thank you everyone for your questions, and it was a pleasure to introduce about the tools as well as the capabilities and how we solve the problems of the engineer. So over to you, Cecilia.
Yes, I wanted to talk a little bit about our next webinar. The topic is web-based digital thread for systems engineering. And why should you join this webinar? You will see the feasibility of RAT online for requirement authoring and traceability within Jira. And you will see how SES Online works for impact analysis, orphan detection, semantic search, and navigation across the digital thread. And what would SES Engineering Studio save on your current project? Don't hesitate to contact us for more details. You can book a meeting with one of our consultants through our website. We also offer a requirements analysis service to check the quality of your requirements. And of course, you can try our tools if you're interested. You can also find further information on our website, reusecompany.com, and on our YouTube channel at The Reuse Company. We will finish here, so thank you, Rayas, and thank you everybody for attending. We hope to see you soon. Goodbye.
Thank you everyone. Bye-bye.